Welcome back to BSpice. In this session, we'll discuss about control valve material selection. One of the very important aspects while designing the control valve. Of course, in our BSpice, we have uploaded many videos on this control valve, data sheet, design consideration, and trim, noise consideration. All these we have already covered. In fact, the question and answer, everything. But this one is a detailed of what we have covered in the data sheet. We would have put there, right? Material selection, carbon steel, or maybe, hardened stellite, right? So we are going to dive deep actually. So this will help you to master the material selection for the control valve. So with that good note, let's get started. Selection consideration. When we talk about selection consideration, you know, there are so many factors actually. So factors in the sense, one is the material properties, and the other is the characteristics. Why these all needed? So these are required to ensure compliance with a good valve design standard and importantly the valve compatibility with a specific application. So these are the two aspects, material properties and characteristics. We need to focus when we go for this material selection. Okay. So when we do this material selection, okay, when we discuss about the material selection, when we investigate about the material selection, we need to focus on the material strength. What is this strength? See, it's the ability to retain pressure and to withstand considerable pressure drop, which is very, very important, vital aspect, parameter in the control valve, right? Yes. So that is the material strength. Then additionally, we also need to focus on this, you know, thermal expansion coefficient. Thermal expansion coefficient. So basically, thermal expansion coefficient of valve components must be matched in order to prevent the dimensional distortion that could result in gasket leak and excessive stresses on the valve components. Okay. So this is a second item. So thermal expansion coefficient. Okay. So thermal expansion coefficient. So for all components must be matched. Okay. So basically here it is a measure of, you may ask what is the thermal expansion? Basically it's a measure of how much the object will expand or contract when it is heated or cooled. So that is the general, meaning actually. So basically the valve components must be matched in order to prevent the dimensional distortion. Okay, that is a point. Then wear properties actually. Wear properties. What is this wear properties? See, basically it's the resistance to wear, such as sliding wear and oxidative wear. So you may ask a question, what is the sliding wear? Sliding wear refers to the process in metals. So in our case, it's a body, right? Control valve body, where the material removal occurs through either oxidative processes, probably a mild wear or a plastic flow of surface, leading to the formation of metallic debris, all these. So basically it's a one kind of wear in a metal. Okay, so that is what. Then we have a oxidative. What is oxidative wear? See, oxidative wear is a type of wear again that caused on the surface of the material under non-lubricated condition. See, basically it's one of the most common forms of corrosive wear because an oxygen rich environment is a typical environment in which this process occurs actually. So it's basically a process which occurs on the surface of the material under oxygen rich environment. So this is the oxidative wear. So we need to focus on all these actually. If your valve is under subjected to the oxygen rich environment. Okay. Then we have a wear couple compatibility. What is this? Resistance to galling. So basically what is galling? Again, galling is a form of wear caused by adhesion between the sliding surface. Okay. So this is the galling. So galling in control valve, if we refer it, it's basically an unexpected adhesion between two metal surface in the sliding contact, resulting in a frictional damage or scission. Okay. So these are the things when we talk about selection consideration, we need to selection of material, we need to focus on all these, meaning material strength, thermal expansion, wear properties, and wear couple compatibility. All these. Okay, few more to add on. Now, we will talk about general properties. Okay, general properties. Okay, uh, okay. One moment. So when we talk about cast iron, there are many aspects actually. I will take you through one by one. Give me a minute. Give me a minute. Yes. Material selection, right? One moment. Yes. So when we talk about the material selection consideration, so we talked about the material selection criteria, all those. Now we will focus on the general properties of the material. So properties means, you would have selected cast iron, you would have selected carbon steel, you would have selected, chrome moly steel or cast alloy steel, right? And you would have selected stainless steel. But you need to know what is this, benefit and what type of composition and what type of application this is suitable. Okay, now we'll talk about the cast iron. So cast iron is a low cast, non-ductile, meaning brittle material that is typically specified only for low pressure steam, water, gas, and non-corrosive fluid. So the point is, it's a brittle, friends. It's a low cast, and only for low pressure steam. Okay. Cast iron is brittle, yes, easily fractured and cannot be welded repair. Weld repair cannot be weld repair. Okay. Now we go to the carbon steel. So carbon steel, we have two types, WCC and WCB. You know, right? Yes. So you may have a question here, right? Yes. So what is WCB, right? In control valve, right? So some of you are aware, but yeah. See, it is basically what you call weldable cast B grade steel. Actually, it's WCB material originate from the cast steel actually. So we call it as like weldable cast B grade steel. So that is the meaning of it. Okay. Then we have WCC. What is this WCC? So again, it's a carbon steel grade. Carbon steel grade. Okay. So it covered by ASTM A216 standard actually. Okay. So basically we can also substitute this. WCC is a standard substitute for the WCB. Okay. So basically we call it with the letters, WC, A, B, C, all indicate the strength value of the steel grade from low to high. So that is the meaning. Okay. Got it? Okay. So coming back to the point. See, carbon steel are popular body and bonnet material because of their low cost, good strength, or a wide range of temperature condition. That is the point. Carbon steel. You would have seen, right? Yeah, many application. Of course, when we prepare a data sheet, we align with the piping actually, but we should also know the benefits and the properties, all these. Okay. So then we talk about cast alloy steel, or we call it as a chrome moly steel. Okay. So the cast alloy steel or chrome moly steel, we call it as a C5 WC9, is also a standard body and bonnet material. We can choose this also. I'm going to explain in the, with the tabulation, with the detailed application, there where to use what type of casting. Okay. Cast alloy steel are typically specified for application that require more erosion resistance on higher pressure and temperature rating. You got it now, meaning why we are using this. See, here of course we talk about wide range of temperature condition, but if it is a high pressure and erosion and high temperature, then we can go with this option. Okay, right. So cast iron covered, cast carbon steel covered, and cast alloy steel covered. Now we have few more actually. Cast stainless steel. See, various grades of cast stainless steel like CF8 or CF8M are typically specified valve bodies and bonnets that are applied in high and low temperature application and in corrosive application. Again, friends, don't get confused why I'm giving all these. See, when we prepare a data sheet, we align with the piping spec. So whatever is the piping spec says, so we have to use that material. But here my intent is to give the detail of each and every aspect of the properties, application, usage, everything. Okay, I hope you got it right. Yes. So this is what. Now, stainless steel is available in different grades. As you know, 410, 416, 316, right? Is also the industry standard trim material for mild to moderately corrosive and erosive application. So these grades we can use for this corrosive and erosive. So another what do you call it? The benefit. If you use the stainless steel, its increased durability and erosion resistance is achieved through hardening of material. We can use this, we can increase the durability and erosion resistance by hardening of the material. How? Either by heat treating or cold work through the application of coating. So what sort of coating? Like electroless nickel coating or hard facing such as stellite. You would have seen, right? You would have heard, right? Stellite material, right? Yes. So this is basically achieved by the heat treating or cold work through the application of coatings such as electronickel coating or through hot facing such as stellite. Okay, I hope this is also clear. Now we go into the nickel, high nickel content alloy. So high nickel content alloy include Monal. It's a very good. Inconel, that is also very good, and Hastellite, right? All these are used for selected valve bodies and trim component that are applied in extremely corrosive and caustic application. Highly corrosive and caustic application. Okay, friends, got it? So few more to add on this. And cobalt alloys. Cobalt alloy, such as alloy 6, again stellite, are hard and tough material that are commonly specified because of their superior erosion resistance. So critical surfaces of trim and bodies may be hard faced with cobalt material. See, by how we are doing it, by well depositing the material, or the trim components may be machined from wrought and cast forms of material. So this is about the cobalt alloy. Then others also there, others in the sense that ceramics, ceramides, other hard and tough materials such as tungsten carbide and ceramics are sometimes specified to provide erosion resistance in exceptionally erosive. Exceptionally, exceptionally. There is no other way. You have to go with this. So these are the some of the general properties. Now I go to the climax. Climax in the sense I summarized it. Okay. So this is what I have classified actually. See, material family. Example, material. Then primary characteristics and this application. This will give you a complete, guidance, complete guide for selection. Okay, now we talk about cast iron. So we have a cast iron, right? So it's a low cost, brittle, non-weldable, right? Then limited to low pressure water, steam, gas, and not allowed for many control applications. So with that, we will reject this. Now we go to the carbon steel, WCC, LCC, WCB, right? So it is a high strength, ductile, weldable, and limited to 800 degree Fahrenheit. This one we need to watch out for. This is standard material for control bodies, but again I'm saying we need to align with the piping spec. Okay, then alloy steel, C5, WC9, LC3. So here the temperature rating above 800 degree and to minus 150, sorry, not degree Fahrenheit, and to minus 150 degree. We can use this. So it offers better erosion resistant than carbon steel. Certainly a good one. So the valve bodies for high and low temperature and for moderately erosive. This is the point. Moderately erosive. Then we have a stainless steel 300 series, which is very, very common, 304, 316, 316L. So it gives a good balance of corrosion resistance, strength, and cost also, a competitive cost. So higher temperature rating than carbon steel, of course. Poor wear, with a poor wear actually, not much of wear. And therefore is often ENC coated or hard faced. Yes, so hard faced like with Stella, all these. Another point, coated or hard face materials are resistant to corrosion and erosion. That is a general point, right? Yes. So now when we talk about the application, valve bodies for corrosive, erosive and high temperature application, we can use this. And a standard material for valve trim, we can have this hard face with stellite also, we can use it, right? Okay. Then we have a 400 series that is superior again, 410, 416. You would have heard all 300 series, right? Now we have 400 series, which is superior than that. So it gives a higher hardenability than 3000 series, 300 series. So less corrosion resistance than 300 series. That is the issue actually here. Here the corrosion resistance is good, but here lesser. And extremely difficult to hard faced for erosion resistance. Erosion is okay. Extremely, if erosion, higher erosion, we can use this. Okay. Then typical application, seat ring, we can use this, valve plug, we can use this, and other trim component that require hardness and erosion resistance. We are talking about erosion, not corrosion, friends, erosion resistance. So there is a difference, right? Yes, correct. So now we are done with SS. Now, precipitation hardened stainless steel. So this is basically, we call it as 17 pH stainless steel. So this is excellent hardness strength and excellent corrosion resistance. Whereas in 400 series, we have some limitation on corrosion, right? But this guy have excellent hardness strength and corrosion resistance. So basically, we can use this for valve stem, gauges that require strength and erosion resistance. Okay. Then we have a nickel alloy, which is very, very superior. Cast alloy, Inconel, Monel, right? So all these are excellent to corrosion, but bit of expensive, of course, right? Yes. So we can use this for bodies and trim in highly corrosive environment. Okay, right. Then cobalt alloy. Cobalt alloy means alloy 6 stellite. It's a very tough, excellent resistant to erosion. Corrosion resistance is equivalent to 300 series. Okay. So here as a hard facing applied to trims, yeah, we can use as a trim with a hard facing, and also in cast form, like, seat rings or maybe for other erosion resistant trim, we can use this cobalt alloy. Then ceramics, it's basically, the material is basically a partially stabilized zirconia. We use this for extreme toughness, erosion resistant, of course, good corrosion. So again, we use this for seat ring, plug, or highly erosive and corrosive application. It's extreme case, extreme case. Then cermets. This is a tungsten carbide. Extreme toughness, erosion resistance, but again poor corrosion resistance. That one you need to watch out for. So again, this is used for seat rings, plugs for highly erosive application. So this is basically, I just want to give you some summary, friends. This is all actually self-explanatory. If any questions, you can write to me. Thanks for watching. See you in another video. Take care. Bye-bye.